All right. Last video of the first half of chapter 8, which is super exciting. We're still talking about multiplying binomials. We're just going to look at some interesting cases, some situations where some things can arise that are different than what are different than like the normal type problems. So again, as a warm up, before we get into multiplying or distributing, I suppose I should real quick. Our EQ is how can I multiply binomials with other binomials, which is the same EQ as last time, but again, we're going to look at some special circumstances. Again, factoring is the opposite of distribution. Okay, so if I'm factoring the GCF out, I am writing a distribution problem to which I already have the answer. Okay, so if I look at these three terms, 7x squared minus 35x and plus 21, what do they have in common? Well, 7 can divide all three of those numbers, and there is no x in the third term. So the GCF of this is just 7. So then I'm dividing each term by 7 and writing that what's left over, basically. And so that's our solution. This is our expression that if I were to distribute would give me back the original. Okay. And don't forget, one of the things when we talked factoring is if you see a negative number to start, we're going to include the negative sign when we talk about GCF. So 5, 20, and 15 can all be divided by 5, but again, I'm going to include the negative there. And then x to the third, x to the second, and x to the first, they all have x. But I can only take 1 from all three of those terms because my third term only has 1 to give. So dividing by negative 5 and taking one of the x's away will leave me with 1x squared there. 20 divided by negative 5 is minus 4x. And 15 divided by negative 5 is negative 3. There was only 1x, but I'm taking it out as part of the GCF, so that minus 3 is by itself. Okay, so factoring. But again, we're going to focus on, I know we've been switching back and forth pretty quick, but they do go hand in hand. One of the most common mistakes we see in intermediate algebra, advanced algebra, geometry, like every math class, is when a student sees this, x plus 3 to the second power, thinking they can distribute the squared. And that is incorrect. That is not true. Okay? I cannot distribute. I can't just square both of those things and call it x squared plus 9. Okay? Cannot tell you how often that shows up. What we need to do today is get you thinking about, okay, what happens and what am I supposed to do
this is a test page
if I see this?
Okay. 1, 2, 3, 4, 5.
No, that's it. Okay. So x plus 3 to the second power, we need to think of it. If you think about what this second power means, right? That second power means you're squaring something, and to square something means you are multiplying that thing by itself. So x plus 3 to the second power means the binomial x plus 3 multiplied by another binomial x plus 3. So if you see that second power, highly, highly recommend, at least I do, that you write it out like this, x plus 3 times x plus 3. And if you remember to do that, this is no different than the previous video. It's just distribute, or if you want to do the box method, x plus 3 times x plus 3. Just a reminder, I'm going to multiply to fill each box.
This is a test page for Sean. 1, 2, 3, 4, 5.
Okay. And then in the middle here, I have plus 3x and plus 3x. I appreciate your patience, by the way. 3x and 3x can combine to be 6x. So I get x squared plus 6x plus 9 is my fully simplified expression for that. Okay, so that's how we square what it means to square a binomial. Oops, my face is in the way. It means we're going to write it out as two identical sets of parentheses, and then we're going to go ahead and distribute. So go ahead and take a minute. and try these two out and see how you do. Since we're going to move pretty quick through this, we've had a couple days now of multiplying and distributing. If part of what I write down isn't making sense, make sure to bring it up with either me or whoever your teacher is. Like, hey, I saw this. I don't really know where he got this thing. Or you can just comment on the video and let me know what your thoughts are. Now, I jumped the gun a little bit there. Minus 4x plus 16. If you want and you identify that you can combine those like terms, you don't have to write it down twice like I did here. You could go right to x squared minus 8x plus 16. Okay. So just if you want to, as you get more comfortable with this, if you want to kind of jump some steps from what I'm writing down, that's totally fine. Just go slow, be careful, don't make any silly mistakes. So 2x times 2x, remember I'm multiplying the whole numbers and I'm adding the power, so it's 4x to the second. Here I have 10x, here I have another 10x, and here 5 times 5 is 25. Okay. 4x, or the 4x squared doesn't have any other x squareds to combine with. This 10x and that 10x I can combine to be 20x. And then the 25 again is by itself, but this now is my simplified expression, or what we as math teachers are looking for the answer. Okay, you are writing this problem. You're multiplying and combining like terms, basically. Okay, so if you see a second power outside of parentheses, don't distribute that squared. Write it out twice. Okay, take the 4 seconds it takes to write it out like this, so you don't do any silly mistakes. Okay, 2x plus 5 squared means 2x plus 5 times another 2x plus 5. Okay. All right. And then finally, and this isn't a vocab word you'll need a lot right now, but you'll hear it, and you may have heard it in like a Spanish class, and that is a conjugate expression. Okay. In math, what it means to be a conjugate is that you have a binomial you have two binomials that are identical.
This is a test page for Sean.
1, 2, 3, 4, 5. What it means to be conjugates is that
5.
They're the exact same thing, except the second term, one of them is minus and one of them is plus. Okay. So if you see the word conjugate in math, it means the first term is identical, but the second term just switches from positive to negative. Okay. So the conjugate of negative 2x plus 1, keep the negative 2x, but switch the plus 1 to minus 1. Okay. And you're not going to be tested on, do you know what the word conjugate means? But something interesting happens if I multiply two binomials and they happen to be conjugates. Okay. So if I want to multiply x minus 5 times x plus 5, okay, and I've been doing a lot of these examples using the box method. That doesn't mean you have to. Okay, make sure if you feel more comfortable just doing distribution with it, then go that route. X times x is x squared plus 5x. Down here is minus 5x, and then negative 5 times positive 5 is negative 25. When I look at of those 4 boxes, can I combine any of the 4? Are they like terms? I see that the plus 5x I can combine with the minus 5x. Okay. Now everybody knows that 5 minus 5 is 0. What that doesn't mean is that you should write your answer as x squared plus x minus 25. Okay. I see this a lot. Students see that 5 and 5 is 0, so they think I should just not put a number in front of x. But remember, a variable by itself really means that there's one of that variable. If 5 minus 5 is 0, which it is, this is gone. Okay, that middle term is not even part of the solution anymore. Okay, So when I multiply those conjugates and I combine the like terms, the 5x and the minus 5x, they make a 0, cancel out whatever verbiage you want to use. But this is my final answer, so to speak. Okay, it's just x squared minus 25. So I took a binomial, multiplied with a binomial, and I got a binomial as an answer, just x squared minus 25. Okay. These are conjugates, so you should have some sort of 0 canceling out. But go ahead, pause, try this, and we'll wrap up this first half of chapter 8. All right, x plus 7 times x minus 7, x squared minus 7x plus 7x, and then minus 49. Sure enough, negative 7x and positive 7x make 0. So I have x squared minus 49. And this is done. I do the same thing over here. 3x minus 8 times 3x plus 8. 3x times 3x will give me 9x the second. That'll give me plus 24x. That'll give me minus 24x, which is good because that's the cancellation I'm looking for. And then positive 8 times negative 8 is negative 64. So my final simplified version of this is 9x squared minus 64. Okay. So conjugates, when you multiply, they will cancel each other out. So to summarize, all I want you to think about is that 2x plus 3, please, 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 if you see that squared, write it out as 2 identical binomials. Now, just because we got done with conjugates, realize that this is not a conjugate. Okay, these are not one is plus 3, one's minus 3. These are both 2x plus 3. And then we distribute. So it doesn't quite answer the EQ for this one, but again, this is really the stress, is that if it's second power, is that you write it out as 2 identical binomials, and then go ahead and multiply. Boom! First half of chapter 8 in the books.